See ma. So next concept which we are studying is common potentials if capacitors are connected. Okay, so see here. So this is one capacitor whose capacitance is C1, and this is another capacitor whose capacitance is C2. Clear? No? So they are charged to charges of Q1 and Q2. Okay, ma? And their respective potentials are V1 and V2 between the plates of the capacitor. These are the two capacitors which we are taking. Clear? No? Capacitances are C1, C2. Charges stored are Q1, Q2. And potential difference between the plates is V1 and V2. So it means that one plate will be positive plate and second plate will be negative plate. No, ma? Similarly, this is a positive plate and this one is a negative plate. Now these capacitors I can connect in two methods. Ma. First of all, I can connect to these positive plates and I can connect the negative plates. So this is one method of connection. Second method is I can connect a negative plate to positive plate and a second negative plate to first positive plate. So these are the two methods of connections. Are you able to understand? So let us see the first type. Okay, ma? First type of connection we will see. See. So completed now this one? So this is a very important concept asked many times in the previous examinations, so listen very carefully. So case number 1, which is the first case we are discussing, positive plate connected to positive plate of second capacitor. Okay, ma? It means how can I connect to them? This is one capacitor, positive plate and negative plate, and this is another capacitor which is again connected to positive plate and negative plate. Is it clear? Now can you say what happens? Em jarugutundi cheppandi. Both are charged capacitors only. Previously this one was having a charge of Q1, this one was having a charge of Q2. Capacitance of this one is C1, capacitance of this one is C2. Okay, ma? And potential of first capacitor was V1, potential of second capacitor was V2. So if I connect like this, what happens? This is parallel type of connection. How can you say? How can you say? We are not connecting any battery here. Battery we are not connecting. Are you able to understand? No? So just these are charged capacitors. Both of them they are charged. Charged to potentials V1 and V2 and charges stored are Q1 and Q2. If positive plate connected to positive plate, what happens? Anybody? See, out of these two potentials, one potential will be greater than another potential. No? Okay. Let us consider V1 is greater than V2. Okay. If V1 is greater than V2, what happens? Charge always flows from which potential to which potential? Higher potential to lower potential. Already we have studied. No? So therefore, if V1 is greater than V2, then what happens is, no, Vinali. Okay, ma? So if V1 is greater than V2, what happens is charge flows from first plate of first capacitor to first plate of second capacitor to first plate of second capacitor. So this is what happens. Clear now? So this positive charge, it starts flowing from first capacitor to second capacitor. Or you can say that redistribution of charges will take place. Redistribution. Okay, ma? So redistribution of charges takes place. Okay. So this redistribution of charges will take place up to which position? రోజంతా జరుగుతూనే ఉంటుంది until they get equal potential. Clear nama? So this, 1 minute. Okay ma? So therefore this redistribution will occur until both of them reach same potential. Okay ma? Until both of them reach same potential. So this is the most important point. Understood nama? So if potentials are different, if potentials are same, then no problem. Okay ma? But if potentials are different, definitely charge flows from which plate to which plate? Plate at higher potential to plate at lower potential. And this redistribution of charges will take place until both of them they gain the same potential. Understood now? So if a charge flows from this plate, what happens to its potential? Decreases, no? Charge is entering into second plate. What happens to this potential? Increases. So slowly higher potential decreases, lower potential increases. Are you able to understand? So at one point both of them they get same potential. Then the redistribution of charges will stop. So therefore, how can I calculate common potential? Common potential, how can I calculate? Anybody? What is the common potential present on both capacitors? రెండిటికి ఒకే పొటెన్షియల్ వస్తుంది అనుకున్నాం కదా. Then how can I calculate that common potential? Anybody? Sima, V is equals to Q by C. This is the formula, no? V is equals to Q by C. So, for total circuit, if I want to calculate common potential or potential on each capacitor, then total charge which is present is Q1 plus Q2, no? Charges have redistributed, that's all. Charges have not cancelled, no? Are you able to understand? No? Charges have redistributed. It means that if charge on first plate has reduced, charge on this plate will increase, no? But whatever it may be, total charge is Q1 plus Q2 only. Charges redistribute ayina enta varaku agani cancel avvaledu kada. So total charge remains to be Q1 Q2 divided by total capacitance is C1 plus C2. Total capacitance, how much I am writing? C1 plus C2. How can you say it is C1 plus C2? How can you say it is C1 and C2? Sima, C1 plus C2 means this is a parallel connection, no? In parallel connection, how do you add capacitances? C1 plus C2 plus C3. In series connection, 1 by C is equals to 1 by C1 plus 1 by C. Like this we do, no? So here I am writing equivalent capacitances C1 plus C2. It means these two capacitors are connected in parallel connection. How can you say? How can you say they are connected in parallel connection? Anybody? Aithe? How can you say they are connected in parallel connection? What is the property of parallel connection, ma? Property of parallel connection? Both capacitors will be at same potential, no? In parallel connection, every capacitor will be present at same potential. Now after redistribution, both of them they are present at same potential only, no? So definitely it means that they are connected in parallel connection. Are you able to understand? No? So this is my equation to calculate common potential, that is potential existing on each capacitor. Are you able to understand? No? So V common. So common potential I can write Q1 plus Q2 by C1 plus C2, or C1 V1 plus C2 V2 divided by C1 plus C2. I can write like this also, because Q1 can be written as C1 V1, no? Q2 can be written as C2 V2 divided by C1 plus C2. Clear, no? Or if you want to write in one more method, you can write like this also. Okay, ma? You can write Q1 dash plus Q2 dash divided by C1 plus C2. Now what is Q1 dash and Q2 dash? These are the final charges after redistribution. Initial charges are Q1, Q2, no? After redistribution, charges will change, no? Those charges are Q1 dash and Q2 dash. Are you able to understand? So what is Q1 dash, comma Q2 dash? Okay. Final charges on each capacitor. Okay. So final charges on each capacitor is given by Q1 dash and Q2 dash. That's it. Have you understood? Right. Sima. So now what we are doing is, these are the two capacitors, no? These are the two capacitors which were charged. Okay. So this one was charged to potential of V1. This was charged to potential of V2. So this was positive plate, and this is also a positive plate, but these are negative plates, no? So positive plate of first capacitor connected to negative plate of second capacitor. This is the connection. Understood, no? Positive plate connected to negative plate of second capacitor. Now can you say what happens? Anybody? Huh? Anybody? Now let us again consider V1 is greater than V2. Now can you say what happens now? Potential of first capacitor is greater than potential of second capacitor. What happens? Anybody? Again charges will flow, that's it. Are you able to understand, ma? See, V1 is greater than V2. Positive potential is greater than positive potential of second capacitor. Now, but this one is negative potential, no? Negative potential will be further less than V2. Ante kada? So, where is plus V2? Plus V2 is present on the positive plate. Minus V2 is present on negative plate. Minus V2 is bigger or plus V2 is bigger? Plus V2 is much larger, no? So it means that more amount of charge will start traveling from positive plate to negative plate. So again, charge will continue to flow. How can I call? Just I will call plus Q. Plus Q charge starts flowing from first plate of first capacitor to second plate of second capacitor. That is negative plate of the second capacitor. But problem here is that here positive charge is flowing, no ma? But here what is the charge present? Negative charge is present. So these positive charges and negative charges, some of them they get cancelled with each other. But previously it was not the case, no? Previously charge was flowing from which plate to which plate? Positive plate to positive plate. So positive charge and positive charge never get cancelled with each other. Are you able to understand? But here in this condition, positive charge is flowing to negative charged plate. So here negative charge is there, here positive charge is there. So some of the charge will get cancelled with each other. Are you able to understand, ma? Some of the charge gets cancelled and the remaining charge comes and gets deposited on the second plate. Are you able to understand, ma? It means now this one also behaves like a positive plate. This one also behaves like a positive plate. Same concept of transfer occurs here also. Same type of transfer occurs on the other side of the plates also. Transfer will happen on both sides, no ma? Here also charge will flow. Here also charge will flow. Charge will flow on both sides. Again charge will flow up to which condition? Again until both of them they obtain a common potential. Okay. So therefore after transfer of charges, what happens? Clear, no ma? So capacitances are same C1, C2. Okay, ma? Common potential is V and V. Okay. This is also positive, this is also positive. This is negative, this is also negative. That is what happens. Are you able to understand? Okay, ma? So previously positive, negative, no? After redistribution of charges, both sides will become positive and both sides will become negative. Okay. So what are the note points here? We have to write note points is that as positive plate is connected to negative plate, okay ma, some of the charges will get cancelled, okay ma, and again same concept, this redistribution of charges will occur until you reach a common potential. Okay, so V common, now how I can write Q1 minus Q2 divided by C1 plus C2. This is how I can write. Okay, now can you say why I have written Q1 minus Q2 ma? Q1 minus Q2 enduku rasana cheppandi. Some of the charges they get cancelled, no? How much charge will get cancelled? See ma, consider on this plate 10 microcoulombs of charge is present. On this plate minus 4 microcoulombs of charge is present. Okay, so charge starts flowing from 10 microcoulomb plate to minus 4 microcoulomb plate. How much charge will get cancelled? 10 minus 4 microcoulombs of charge will get cancelled, no? Huh? So in this 10 I can divide this one into 4 plus 6 no ma? 10 I can divide into 4 plus 6. So this is plus 4, this is minus 4. So this minus 4 and this plus 4, they will get cancelled with each other. What is the remaining charge? 6. Remaining charge is 6. Are you able to understand? Same concept is happening here also. So Q1 minus Q2, it means some of the charges will get cancelled with each other, divided by C1 plus C2. Now again the potentials have become common, no? After redistribution, both of them they got same potential. Same potential means series or parallel? Parallel connection, so that's why I am writing C1 plus C2. That's it. Okay? So therefore I can write Q can be written as C1 V1 also, no? Minus C2 V2 divided by C1 plus C2. This is how I can write. Okay? Or you can do one thing also. V common, you can write, okay ma? So Q1 dash plus Q2 dash divided by C1 plus C2. And what is Q1 dash and Q2 dash? Final charges which are present. Okay ma? So therefore Q1 dash comma Q2 dash, what are they? They are final charges on capacitors. Fine. So this is what happens. Sima, when we connect these charges will redistribute, no? Charges will travel from first capacitor to second capacitor. So in this transfer of charges, definitely there will be some loss of energy, because wires will have resistance, no? Wires will have resistance. Because of that resistance, definitely there will be some loss of energy. And how much loss of energy? Again, there are two cases, no? So we will study loss of energy in both the cases. First case is positive plate connected to positive plate. Then energy stored, this is the formula, no? Half CV square. So this is the energy stored in first capacitor, energy stored in second capacitor before connection. After connection, total capacitance is C1, C2, no? And there is a common potential. Common potential is what here? V. So what is V here? V is called as common potential. Arthamatundama? So what is V1 and V2? These are the potentials before connection. What is V? Potential after connection. Understood, no? So therefore, loss of energy, how can I calculate? Initial energy minus final energy. So there is a lot of calculation. So we are not doing all that calculation. Just remember this equation. Clear, no? So C1, C2 divided by 2 into C1, C2 multiplied by V1 minus V2 whole square. So this is the loss of energy in which condition? When positive plate is connected to positive plate. Is it clear? Similarly, if positive plate of first capacitor connected to negative plate, then the loss of energy will be very large. What is the reason? When positive plate connected to positive plate, this is the loss of energy. But when positive plate connected to negative plate, loss of energy is larger. Are you able to understand here? So here I got V1 minus V2, but here I got V1 plus V2. So it means definitely loss of energy is more. What can be the reason? Some of the charges will get cancelled also, no? So definitely loss of energy will be greater. And this is the equation. Are you able to understand? Right. Ante antava? Okay. Sima. So 5 microfarad capacitor is charged to a potential difference of 100 volts. Okay, ma? This is one capacitor. Capacitance is 5 microfarads. So potential difference is how much? 100 volts. Then it is connected to uncharged capacitor. Capacitance is 3 microfarads. But what is the charge present on it? Charge present is 0. There is no charge. Are you able to understand, ma? If there is no charge, what is the meaning of this one? Which plate is positive, which plate is negative? Charges లేనప్పుడు మీకు సింబల్స్ ఎలా వస్తాయి? There are no charges. So there is no charge on first, there is no potential on first plate, there is no potential on second plate. This is not positive, this is, both are neutral plates. Because charges are not present, no? Now how can you connect them? You can connect them as you like, because second one is a uncharged capacitor. Are you able to understand, no? So therefore, this is my first capacitor and this is my second capacitor. Clear, no? So calculate potential difference between the capacitors. So this is positive plate, negative plate. This is not a positive plate, this is not a negative plate. Both of them, they are neutral plates. But a charge will flow from which plate to which plate? Charge definitely flows from positive plate to uncharged plate. This is what happens. So therefore, what is the equation of common potential? Charges are not cancelling, no ma? Are charges cancelling? No, charges are not getting cancelled. So which equation I can use? So Q1 plus Q2 divided by C1 plus C2. Or I can write C1 V1 plus C2 V2 divided by C1 plus C2. So this is the equation for common potential. Clear, no? So what is the capacitance of first one? 5. 5 into 10 power minus 6. Okay. And what is its potential? 100. What is the capacitance of second capacitor? 3. 3 into 10 power minus 6. Now what is the potential on second capacitor, ma? Second capacitor paina potential enta? Before connection, there is no potential. Okay, V2 is 0. Why V2 is 0? There are no charges, no? There are no charges. If there are no charges, there is no potential. Understood, no? So multiplied by 0 divided by C1 plus C2. What are the values? So 5 plus 3 into 10 power minus 6. Okay? So 10 power minus 6, 10 power minus 6, 10 power minus. This is already 0, no problem. So if I do this total calculation, common potential will be how much? V common is equals to 5 into 100 divided by 8. Correct only, no? So it is 500 divided by 8. So answer is 62.5. 62.5 volts. That's our answer. Clear? అంత సీరియస్గా ఉండాలి. Sima. So, two capacitors 4 and 6 are connected in series to a potential difference of 250 volts. So previously they were uncharged capacitors. So this is 4 and this is 6 microfarads. So they are connected to which potential difference? They are connected to potential difference of 250 volts. Clear, no? So if I connect them to a battery, then what happens? They will get charged capacitors, no? And they are connected in which connection? Series connection. It means the charges present on each capacitor will be same. Potentials will be different, capacitance also will be different. Only Q is same. Are you able to understand? Now can you say each capacitor will have how much charge and each capacitor will have how much potential? Because what we are supposed to do after connecting them like this, after making them charged, then we are disconnecting them and we are reconnecting them in parallel connection. Okay, ma? After charging them, we are again disconnecting them. And again we are connecting them in some parallel connection. After connecting in parallel connection, then you are supposed to find a new potential difference and what is the charge present on each capacitor. Are you able to understand me? It means when I have connected to 250 volts battery, first of all I should calculate what is the charge stored in each capacitor and what is the potential present on each capacitor. Can you say how can I do it? How can I do it? Clear, no? So just to calculate the total equivalent capacitance. My equivalent capacitance is how much? Okay. C1, C2 by C1 plus C2, no? Because they are connected in which kind of connection? Series connection. So therefore, 4 into 6 divided by 4 plus 6. So 4 into 6 divided by 10. So 6 4s are 24 divided by 10 is how much? 2.4 microfarads. This is the equivalent capacitance. Clear, no? If this is the equivalent capacitance, then what is the charge supplied by battery? Battery will supply how much charge, ma? Q is equals to C into V only, no? Capacitance is how much? 2.4 into 10 power minus 6. Potential is how much? 250. Clear, no? So if you do this calculation, you will get charge supplied by the battery. Let us see how much it is. So charge supplied by the battery is 6 into 10 power minus 4. So 25 into 24 calculate and same. (25 into 2.4) is it 60, ma? 60 only, no? 60 into 10 power minus 6 multiplied by 10. Correct only, no? So therefore it is 600 microfarads. Is it clear? So what is the, microcoulombs. Okay. So this is the amount of charge supplied by the battery. So this charge will be stored where? This charge store ekkada avutundi? On the first plate of first capacitor, and next plate same amount of negative charge which is an induced charge. On the next plate again same amount of positive charge which is again induced charge. On the next plate again same amount of charge. Are you able to understand me? So therefore can I say that charge on first capacitor is how much? Charge on first capacitor is 600 microcoulombs. Charge on second capacitor? Charge on second capacitor is also same, no? So this is also equal to 600 microcoulombs. Is it clear, no? So on the first capacitor, what is the charge? On the second capacitor also we will have the same amount of charge. Fine? Now what is the potential difference of first capacitor? V1 is how much? What is V1? See, out of total 250, first capacitor will take some potential, no? Second capacitor also will take some potential. So how much potential will be taken by first one? How much potential will be taken by? So V is equals to Q by C, no? So therefore V1 is equals to charge on each capacitor 600 microcoulombs divided by capacitance is how much? 4 microfarads. So micro get cancelled. So V1 is equals to, so 60, 10, 5, 150 na? 150 volts. Clear number? So this is the potential on first capacitor. Then what is the potential on second capacitor? 100. That's all. No? Out of total 250, this one is taking how much potential? 150. Remaining potential will be taken by second capacitor, 100 volts. Because 100 plus 150, 250 only, no? Are you able to understand? No? So therefore V2 will be how much? V2 will be equal to 100 volts. So up to here it is clear, no? So what we have calculated? We have calculated charge stored on each capacitor and potential difference across each capacitor. Now what I will do? Now I will connect them in parallel connection. Are you able to understand? Ma? Make a note up to here first of all. Okay, now see. So we are disconnecting them after charging, and now I will connect them in parallel connection like this. Clear? Ma? See, if anything is not given, it means that we will connect positive to positive. Parallel connection can be of two types, no? Positive can be connected to negative. Positive can be connected to positive also. He did not mention anything. If he did not mention anything, then what is the meaning of it? We connect to positive, negative to negative. That's the meaning of this. Clear, no? So therefore, positive connected to positive, negative connected to negative. So all the potentials, charges, capacitances, everything we have. So can't I calculate a common potential? After connection, charges will redistribute, no? So what is the common potential? Common potential is equals to C1 V1 plus C2 V2 divided by C1 plus C2. That's all. Huh? So what is the capacitance of first capacitor? 4 multiplied by potential 150. Capacitance of second capacitor 6. Potential 100 divided by 4 plus 6. Clear, no? So therefore 600 plus 600 divided by 10. Okay, ma? So therefore it is 1200 divided by 10. It is equal to 120 volts. Clear, no? So after redistribution of charges, common potential will be how much? 120. Previously it was 150, it was 100, no, ma? So potential of this one is reducing, potential of this one is increasing. Both of them, they got a common potential of 120. Is it clear? So once I get common potential, now can't I calculate a charge stored? So charge stored on Q1 dash, final charge. Q is equals to C into V, no? So C1 into V. C1 is how much? 4 into 10 power minus 6 multiplied by common potential is 120. Okay, ma? So 12 fours are 48. 480 microcoulombs of charge. Similarly, Q2 dash, final charge on second capacitor. C2 into common potential. C2 is 6 into 10 power minus 6 multiplied by common potential is 120. So 720 microcoulombs of charge. That's it. Have you understood? No? Very simple concept.